calculate the moment of inertia for uniform mass distribution. As we have already studied, for uniform mass distribution, the moment of inertia is equal to integration of r square dm, where integration is taken along specified limits. The moment of inertia of a rod along the centroidal axis. Centroidal axis basically means the axis passing through the center and perpendicular to the plane. Let us consider this rod, the length of the rod BL and its mass BM, and we are required to find the moment of inertia of this rod along the centroidal axis, that is the axis passing through the center and perpendicular to its plane. For this, let us consider a elementary length dx having mass dm. Firstly, let us calculate the elementary mass dm. We can calculate the elementary mass using a very simple method. Dm can be given as equal to m upon L, that is the mass of the unit length, into dx. Since mass is equally distributed along the rod, we can take dm as m upon L into dx. Since the elementary length dx is placed at a distance x from the centroidal axis, so the moment of inertia di, basically di is the moment of inertia of this elementary length. Di will be equal to x square into dm, which will come out to be equal to x square into m upon L dx. This is the value of di. The moment of inertia I can be calculated by integrating the elementary moment of inertia di along the given limits. In this case, we will select limit minus L by 2 to L by 2. It will come out to be equal to m upon L x square dx, and the limit will be minus L by 2 to, which will come out to be equal to m upon L will be taken to be common since both are constant. So it will come out to be equal to m upon 3L. Putting the limit, it will be equal to L by 2 whole cube minus L by 2 whole cube, which will be equal to L cube upon 8 plus L cube upon 8, which will be equal to m upon 3L multiplied by 2L cube upon 8, which will be equal to 1 upon 12 ml square. As we have calculated the moment of inertia of a rod along the centroidal axis, similarly, we can calculate the moment of inertia of this rod along other axis.